Let's see another type of while loop that does not have a fixed number of iterations. In this case, a search loop. A search loop always runs until something happens. Okay, for example, we might be searching for one particular element inside of a data structure, of a list. While you have not found this, keep looping, keep looking for that thing you're looking for. Okay, that's a very common use of search loop. Here we have another one. Let's see how long it takes to generate a multiple of 7. Okay, so we will have, let's copy this again and run it here. So we have a variable to initialize, to count how many times we loop, because we will write it out later. And then what we do is that at every iteration we generate an integer between 1 and a limit that we have defined, print it, and see in the next iteration of the loop if it's a multiple of 7. This percentage thing is the integer reminder, the division, the reminder of the integer division. Okay, so here we do it again, and we loop and loop and loop until we stumble on a 7. This time it took 11 tries, and this time it took only 1, because the first time I already got 7. Okay, and so on and so forth. I also got 7 here. Here I got 21, sorry. Okay, so this time in 3 I got 21, which is also a multiple of 7. So it took me just 3 iterations. The condition is that this random number is a multiple of 7. The first time I initialize it with a dummy value, number 1, which is not a multiple of 7. So I make sure that I will enter this while loop the first time. Then at every iteration in the body of the loop, what I do is that I generate a random integer, print it, and just count how many iterations I'm doing, and so on and so forth until this becomes true. Okay, so here too the number of iterations is not fixed. There are other ways to make the code more complicated. Here we are already seeing how we can use ifs inside of whiles, that we can have whiles with iterations that run for different times. Here in this case we are going to use a bit of a more complicated condition. So for example, here we could add a maximum number of iterations. In this case 25. If you iterate for 25 times, you should stop, okay, and say this did not work. Let's run this one. Okay, so here I'm going to be running this and see, okay, I run it and it could be generated in 3 times. This took 3 tries again. I'm being curiously lucky that it always takes, okay, sorry, let's give this maximum number of iterations of 10 times. Okay, let's start by here. So what I have added is this part of the condition. So my number of iterations has to be smaller than a maximum that I'm giving it here, and I can run it a few times. In this case it took 4 tries, in this case it took 10 tries. Okay, sorry, it could not be generated in 10 tries. I tried 10 times and I got here. Okay, every time I come here I'm checking whether or not my random number is a multiple of 7 like I was doing before, but here, and I'm also checking whether or not I'm already at the maximum iteration number. And if I am, I also exit the loop. And here in the end I check what happened. If my random number is a multiple of 7, then it means I finish with whatever number of tries is in the I variable. If not, if my number is not a multiple of 7, I could not generate a multiple of 7 in the number of iterations that I had. like happened here. So making my condition more complex, in this case giving it 2 clauses instead of 1, has made my code more flexible. Now I can make it stop in 2 different ways. More often than not, this condition is codified, this condition, whether or not the random number is number 7, is codified with a Boolean variable. Okay, for example, here we have the same thing that we had, but now with a Boolean variable. Let's see it here again. Okay, and this is running, could not be generated in 3 times. Let's give it, I don't know, 8 times. Okay, this time it took 4, this time it took 1, this time it took 6, 5, this time it could not be generated in 8 times. Okay, so it's the same structure, only I have now a variable, Boolean variable, that starts at false and then is changed to true when I find what I'm looking for, when I generate a random number. Okay, so, and this structure with this variable here is the most common use of the search loop. Okay, notice that this found equals false has exactly the same truth value as not found. Okay, so I can run the exact same code writing here not found. Found equals false is true only when found is false, which is the same thing as saying that not found is true when found is false. Okay, in this case it took 1 try. Now it took, sorry, could not be generated in 8. Now it took 1. Now it took 4. Okay, so this code with not found here is the most general structure, most widely used structure of the search loop, in this case with a Boolean variable used directly in the condition. To finish with simple for loops, let's do a slightly more difficult problem, which is the Fibonacci number problem. As you know, the Fibonacci sequence starts with 1 and 1. These are the 2 first Fibonacci numbers, and then every Fibonacci number is generated as the sum of the 2 previous ones. Okay, so previous is 1, current is 1, and then every time I store previous somewhere, then previous becomes current, and current becomes itself plus the previous value. Okay, so initially everyone is 1, and then I stored one of the ones in previous, then the current becomes the previous, and the current is added to the previous to generate the next one, and so on and so forth. Okay, and by running that I get the number of the first n Fibonacci numbers. I have the Fibonacci numbers smaller than a quantity. Okay, so I generate Fibonacci numbers until I go bigger than, in this case, 500, for example. We can do it a little bit more compact, and we can do it even a little bit faster because we have less instructions if we know a little bit about the problem. Okay, and one thing that I can do is that instead of needing that auxiliary variable, I compute the new current by adding the 2 numbers, and then because I still have the previous, I can now subtract the previous. So instead of having 3 variables, 1 auxiliary variable, I can use this, let's say, arithmetic trick to make the code shorter. This is not particularly that much better than before, but a nice thing here is that knowing the mathematical problems of the mathematical properties of the problem allows me to write shorter code. Okay, so programming is also a discipline where knowing what I'm doing and knowing the problem that I want to use my code in can help me quite a lot. Okay, here you have some possible codes that you might want to try, and I heartily recommend that you try. You only learn coding by coding.